Today, we are going to start solving equations that are actually inequalities. I said that wrong. They're not equations. They're inequalities. This is lesson 2.4. So we're going to talk real quick about what inequalities are. I put a number line up here and reminding you the symbols less than and greater than, because any number that falls to the left of another number is less on the number line is less than that number, and any number that falls to the right of another number is greater than that number. What we will also see here in Algebra 2 are greater than or equal to signs. This is what it looks like. You have a greater than sign with the straight bar underneath it, and less than or equal to signs. All right, we're going to be talking about inequalities. So when we solve inequalities, the solution set is whatever makes that inequality true. So I've got a couple examples right here. Stop about right here. So I put the first one up. X plus 3 is less than 6. And I want to solve that for 5. I want to see if 5 makes it work. 5 plus 3 is less than 6. Well, we know 5 plus 3 is 8, and that is not less than 6. So that inequality is false. Here, 4x minus 1 is less than or equal to 3x plus 2 if I put in 3 for x. So down here I put 3 in for x. And so 4 times 3 is 12, and 12 minus 1 is 11. That's on my left-hand side. I put 3 in for x here. 3 times 3 is 9, and 9 plus 2 is 11. Well, that is true because 11 is less than or equal to 11. So since that or is in there, that makes it true. How do we graph inequalities? We want to show the solutions on a number line. So I put 2 number lines up here. And I just put a simple inequality, x is less than 2. So to show that on the number line, I circled 2 because 2 is not included. But everything to the left of it is included. And this is the solution set. And this is how you read it. X such that x is less than 2. Whatever number this is, as long as it's less than 2, it's going to make this work. And this line right here means such that. Over here I put x is greater than or equal to 3. When I graphed it, I did color in the circle, the point for 3, because it is included, because it says or equal to. And then anything greater than that. And you would read this solution set as saying x such that x is greater than or equal to 3. Whatever number you put in here could be 3 or greater than 3, and it makes this true. All right, down here, we're going to talk about the addition property of inequality. It says that if you have a number A and it's less than B, and that's true, you can verify it on the number line, then if you have the number A and you add some other number C to it, it's still going to be less than B with that same number C added to it. And this statement is true for if this were greater than, or if this were less than or equal, or greater than or equal. So if you have a number and you add, and it's already less than another number, if you add the same number to both sides, it's still going to be less. And I showed this to you right here using x plus 4 is greater than 7, because this statement is true for any of the inequalities. To solve for x, I'm going to take 4 away from both sides. X is going to be greater than 3 now for this equation to be true. And the way I show that on the number line, like I did earlier, I'm not going to include 3 because it's greater than, it's not equal to it. And then anything larger than 3. My solution set says X such that X is greater than or equal, greater than 3. And notice I did the same thing to both sides. You could say I added a negative 4. All right, now it's a little different for multiplication. I'm going to try to show you the differences here. The multiplication property of inequality says that if you've got a number A and it's less than B, and that's positively true, you can show it on the number line. Then, when you multiply A by some number C and you do the same thing to the other side, it's true for if C is positive. This is going to hold true. It's going to stay less than. But if you multiply A and B by C and it's negative, C is negative, you're going to have to switch the symbol because the negative is going to make it the opposite. So, and I'm going to show you a couple of examples right here. And this holds true for whatever the symbol, whatever the inequality is. So over here on the left, I showed you an example of multiplying by a positive number. So 3y is less than 3/4. Well, in order to solve for y, I have to multiply by 1/3 or divide by 3, whatever, however you want to say it. And I'm multiplying both sides. My inequality is going to stay the same. It's not going to change the value of this to a negative or anything. So y is less than 3/12, and I reduced that to 1/4. So the solution set is y such that y is less than 1/4. If you put any number in here that's less than 1/4, this is going to hold true. So that's why I drew the arrow to this is true because I multiplied this by a positive number, both sides. Here, it's going to be different. My inequality says negative 4x is less than 4/5. Well, to solve for x, I have to multiply by negative 1/4 to cancel out my negative 4 and get my x by itself. Well, when I do it, whoops, didn't mean to mark on that. When I do it to the left side, I have to do the same thing to the right side, and so I'm multiplying the right side by a negative number. That's going to change my sign. So I had to change it from less than to greater than now. Now x is greater than negative 4/20, which reduced to negative 1/5. So x is greater than negative 1/5, and the way I write that in my solution set is x, any number x, such that x has to be greater than negative 1/5. And that means whatever I put in here, if it's greater than negative 1/5, this inequality is going to be true. All right, we will work on these. My guess is this example right here is going to be our toughest one to remember. So hopefully our practice will get us used to that. We'll do some more tomorrow. Thank you.